Hi everyone. Today we are going to present about the solid liquid extraction, which is also known as leaching and its application. For your information, this is the name list of our team members. And now let us move on to what is leaching. So what is leaching? Leaching is a process of washing something useful out of something. Examples like making tea, brewing coffee, and soaking soybean.
Hello everyone, my name is Louis Hong. You might think that leaching is an industrial technical term, but leaching is actually something that regularly occurs in our daily lives. For example, leaching process is used to extract sugar from sugar beet. When sugar beet is boiled, the sugar seeps from the sugar beet into the water. This gives us a sugary water that can be dried to obtain sugar. Leaching is also used to get vegetable oil. We crush the seeds and mix it with certain chemicals to extract the oil from the seeds. Also, do you know how we make coffee from coffee beans? Leaching. When you extract the essence of coffee beans using hot water, that is leaching. Aside from that, certain minerals like copper and zinc are extracted from their ores by leaching. You can see this picture shows clearly how it happens. They usually use acid to dissolve the minerals.
There are some examples of the leaching in environment. First, how rainwater can dissolve harmful chemicals from soil. So when the rainwater seeps into the ground, the acidity allows it to dissolve soluble minerals and chemicals from the soil particles. This process is known as leaching, as the rainwater transports the dissolved contaminants such as the fertilizers, pesticides, or even the heavy metals through the soil layers, potentially into the groundwater or surface water bodies. Secondly, why groundwater contamination can occur. It occurs when the precipitation infiltrates the soil and passes through waste or chemical-rich surface layers. As this water moves downward, it dissolves soluble pollutants such as heavy metals, pesticides, or landfill waste, creating a toxic liquid called leachate. Driven by gravity, this leachate percolates through the permeable layers of the soil and rock until it reaches the water table. Once it enters the saturated zone, the contaminants mix with the clean groundwater and form a plum, which can then travel long distances and render local wells unsafe for use. Here are some importances of environmental protection. It can enhance biodiversity preservation, climate change mitigation, resource sustainability, provide clean air and water, improve ecosystem services, provide socio-economic benefits, educate ethical and cultural aspects, enhance advanced technological innovations, and also policy and education.
Okay, hello, my name is Tiong Sweetheart. So now we'll share about the basic idea for leaching. Okay, so leaching is like washing something to remove what you want. Well, next I will share about the basic step. There are four steps, like a sample step only. So first step is put solid into the liquid, and when the solid is put into the liquid, the useful material will dissolve into the liquid. So we can separate the liquid from the solid, and the liquid now contain the valuable substance that we want. So this is the washing step to take up to remove the things that we want. Okay, thank you.
Leaching is widely applied in different industries. In the food industry, leaching is used to extract oil from soybeans, palm kernels, and sunflower seeds, as well as sugar from sugarcane and soluble compounds during coffee production. While in the mining industry, leaching plays a key role in metal recovery. For example, using sulfuric acid to extract copper and cyanide leaching to obtain gold from ores. And in the pharmaceutical industry, leaching is used to extract bioactive compounds from the plants, which are important in producing antibiotics, painkillers, and herbal medicines.
Next, I would like to talk about the single-stage leaching. Single-stage leaching is a one-time washing process. The contaction between solid and liquid only occurs once. Here you can see a diagram. This diagram is just to show how the process works. Single-stage leaching is very good for simple extractions, for example, soaking dry food in water.
Multi-stage leaching is basically washing the solid multiple times to achieve better results. It is like when we wash clothes, we wash it several more times to remove more detergent. Multi-stage leaching is important to reduce waste and maximize extraction.
There are some real-life examples of leaching. The first one is the extraction of oil from soybean. The soybean oil extraction process begins with cleaning the bean using magnetic drums and sieves to remove impurities like metal and stone. The beans are then crushed, softened with heat, and pressed into thin flakes or puff to maximize the surface area for the chemical stage. After a drying phase, the prepared material undergoes solvent extraction, where a chemical solvent washes through the flakes to leach out the oil. This combination of mechanical preparation and chemical leaching ensures that almost all the oil is successfully recovered from the soybean. Secondly is the palm kernel oil solvent extraction production. The mechanical extraction of palm kernel oil is a sequential process that begins with the crushing of raw palm kernels to increase their surface area, followed by cooking or steaming the fragments to rupture oil-bearing cells to reduce oil viscosity. The conditioned material then undergoes repressing in a mechanical expeller where intense pressure separates the liquid from the solid. This results in two distinct products: a nutrient-rich pressing cake used for animal feed and the extracted palm kernel oil, which is then filtered for various industrial and culinary uses. This diagram illustrates the three main phases of oil recovery, outlining the methods used and the typical percentage of oil recovered at each stage. Primary recovery utilizes natural flow and artificial lift to recover generally less than 30% of the oil. Secondary recovery involves water flooding or pressure maintenance methods, boosting recovery to between 30% to 60%. Finally, the tertiary recovery, also known as the improved oil recovery (IOR) or enhanced oil recovery (EOR), employs advanced techniques like chemical, thermal, or gas injection methods to potentially recover up to 80% of the original oil in place.
Okay, so now we share about the benefit of the leaching process. First one, which is the efficient use of resources, and next is reduce waste and pollution. Third one is save energy, and then is found in everyday products. And next one is help clean the environment. And the last one, which is support recycling.
In conclusion, leaching is an important process used to separate and extract substances by dissolving them into a liquid. It plays a major role in manufacturing industry to produce everyday products such as sugar, oil, coffee, metals, and herbal medicines, while also occur naturally in soil and water, affecting nutrient movement and environmental quality. Understanding leaching helps us gain insights into resource extraction, product safety, and environmental impacts of human activities.
That's all from us. Thank you.